Hello everyone. In this video, we will be discussing in detail about trusses. So basically, what do you mean by truss? And here we'll be discussing about 2D truss. So before that, we shall have discussion on the trusses. Trusses can be defined as combination of many structural members or assemblage of many structural members with the help of pin joints or with the help of your welded joints. So why these kind of combination is required? Why we have to assemble so many beam elements or the rod elements together? So I'll tell you few examples. If you take the roof of any building or any commercial or temporary roofings, if you see, and even some short span bridges. So all these things, if you see, like assemblage of many uh, structural elements, we can able to see that. The reason is, if it is a single element, either a beam element or a bar element, if a load is acting on any one particular point, say for example, that is the point the load is acting or people are walking. So what happens? There are chances because of the repeated load, the failure will take place at that particular point because the stress is focusing on that particular point itself. But if I'm going with for the same requirement, if I'm going with the assemblage of many structural elements, even though the load is applying or acting on any one particular point only, where the load has been distributed to uniformly to all the remaining elements, because all the remaining element is having the connectivity with that particular element where the point load is applied. So that because of the uniform distribution of the load, the failure can be postponed or the failure can be completely avoided. We cannot say that completely avoided, but at least compared to the 1D elements, where definitely the failure chances can be reduced. And here I have taken a 2D element. Here 2D element, you can just a single trussel one rod element I have taken, where here this Q1 dash and Q2 dash is nothing but the local displacement, where capital Q1, Q2, capital Q3, Q4 is the global displacements. You can able to see that since each node is having 2 degrees of freedom, along x-axis and y-axis the deflection will be there. Assume that this is node 1, this is node 2. At node 1, the displacement along x-axis is denoted as Q1, and at node 2, the displacement along y-axis is denoted as Q2. In some textbook, even in our class also, we have denoted it as small q1. Not an issue. Even if you're not comfortable with the capital Q, you can even go with U also. U1, U2 also you can go. And moving to the node 2, the displacements are along x-axis at node 2 displacement is Q3, and along y-axis at node 2 the displacement is Q4. So this Q1 dash is nothing but the summation of both x and y-axis deflection. Similarly, this Q2 dash is nothing but assemblage of Q3 and Q4 deflection. So whenever any problem is given, here this particular sketch you can able to see that it is a 2 truss element. A free body diagram is shown here. So what is the thing is, here 3 nodes are there and the boundary condition is given as there is no point load or any type of load is acting on that one. This node and this node, it is fixed. The meaning of this symbol is it is fixed in both x and y axis. It cannot able to move in x and y axis. Even this also. Here nothing is shown. So what is the meaning? It can able to move freely in both x and y axis. And we have some restrictions when we are solving the truss problem theoretically. So what is the restrictions means? We cannot completely compare the truss boundary condition with the practical cases. As I told you, all the structural members has been connected with the help of a welding joint. So here, because of the welding, usually a friction will be there practically. But the very first assumptions what we are going to consider is that all the truss joints are the frictionless pin joints. Even though it is welded and even though a friction is there, we are assuming that it is a frictionless pin joint. So we need to consider the frictionless pin joint. Second thing is moving to the loadings. Practically speaking, any type of load can be applied. Combination of multiple loads also can be applied, but we are solving the truss problems only where the axial load is acting on. What do you mean by axial loads? Either tensile loads or compressive loads. So that too in the plus x direction or minus x direction or plus y direction or minus y direction. Say for example a point load only, but which is acting on this particular load, but it is acting with certain angle. That angle of load should be resolved into both x and y axis, then it should be solved. So this is the second thing. And third thing, always the load should be applied or acted only on the nodes or the joints. This is also a very important point. So any point also a load can be applied, but we are solving the problem only where on the node only a load is applied. If practically with this particular point a load is acting, means when we are doing the geometry itself, here create a node. This is node 1, node 2, node 3, like that. Create a node on that one. Make sure that the load is acting only on the node. This is the third point. And fourth point is nothing but we are completely ignoring the self weight. That is the body force. We are completely ignoring, but we have considered the body force when we solve the 1D bar problems. So these are the four assumptions we are considering when we are solving the truss problem. So again I'm telling you, listen here carefully. The first point, all the structural members has been connected together with the help of your welded joints. So practically speaking, there will be a friction on the point where it has been joined. We are assuming that it is a frictionless pin joint. And second thing is the loading. Only axial loadings should be applied on the point. And axial load means tensile loads and compressive loads, but it can be of a different direction. That's a plus or minus direction it can be. And second thing is the load should act only on the nodes. And the fourth assumption is the self weight of the body is completely ignored. So this is the basic information about the trusses. And one more thing up. So if it is only 2 or 3 elements and it is an open thing, means we need not to check whether the given component is a proper truss or not. But there are chances that the given structure itself sometimes can be having some 5 elements, 10 elements. That time we need to check check with the equation whether the given like sketch is a proper truss or not. So what is the equation is m is equal to 2j minus 3. So what is the m indicates like total number of members, structural members present, which is equal to 2j. J is the thing but the number of joints, joints the thing but nodes, and minus 3. So it is a common formula. M is equal to 2j minus 3. Assume since it is an open thing, it is not applicable for that problem, but for the explanation sake, let me consider this sketch. You can able to see that what is the total number of members present? 2. So m is equal to 2, which is equal to 2j minus 3. What is the total number of joints present? 3 joints are present. So j is equal to 3. So 3 2 is 6 minus 3. So that way, since this formula is applicable only for the closed structures. So this is also we need to remember. But remember, for the 3 elements, 4 elements, most of the cases we will be solving for the open structures. So the equation we need not to apply. So in the next thing we will be discussing about the transformation matrix, modified stiffness matrix, and method of solving. So all these things we will be discussing in the next videos. Thank you.